Grab your director's chair, everyone, and welcome to this explainer. I am absolutely thrilled to have you here today. Think of yourself as a film director, and your exam paper is your script. Step by step, scene by scene, we are going to build your blockbuster answer for the Cambridge Computer Science exams. Specifically, we're targeting syllabus code 0478, but this strategy is universally powerful whether you're tackling 0417, 2210, or even 9618. Today, we are focusing entirely on text, sound, image, and video storage methods. And here is the golden rule. We are going to cut the filler and keep the action. You see, simply knowing the theory for data representation just isn't enough to secure those top marks anymore. You might know your pixels from your sample rates, your lossy from your lossless, but if you don't know how to direct that knowledge onto the actual exam paper, you are quite literally leaving marks on the table. Today is a dense, highly procedural coaching session designed to help you master this exact topic. So let's stop messing around and get right into the challenge.
Okay, let's talk about the ultimate frustration. It's something every single focus learner faces at some point. You spend hours memorizing the facts, right? You make the flashcards, you read the textbook, yet you walk out of the exam hall, get your paper back a few months later, and boom, you still dropped points. Let's look at a real Cambridge past paper scenario to see why this happens. Imagine an exam question asking how a high-definition video is stored on a smartphone. Now, I want to introduce you to two very different types of students. First up, we have Alex. Now, Alex is a walking encyclopedia. When Alex sees the words video storage, their brain just lights up, and they overload the page with raw computer science facts. I mean, they are writing down everything they've ever learned about bit rates, frames per second, color depth, and complex compression algorithms. But here's the problem. There is absolutely no analysis. It is just a massive brain dump of facts. Then, on the other hand, we have Sam. Now, Sam knows the material just as well as Alex, but Sam panics and rushes. Sam completely misses the command word requirements at the start of the question. The question might explicitly say, explain why lossy compression is suitable for this specific video, but Sam just scribbles down, lossy compression makes the file smaller, and moves on. Boom. Red pen marks everywhere for both of them. They both know the theory perfectly well, but their answers lack precise terminology and context. They completely fail to connect the abstract concept to the specific digital scenario they were given. We are going to fix that today, scene by scene. Here is our structured syllabus for today's session. Think of it as your production schedule. We are going to transform your answers from basic, generic labels to high-scoring, targeted applications. Let's move straight into Section 1, Beyond Isolated Facts. We're moving from simple recognition to deep understanding and application. This slide right here, this brilliantly illustrates the difference between a totally average answer and a true examiner-level response. On the left side, we have rote memorization. This is exactly Alex's approach that we talked about earlier. It's just writing short labels alone in isolation. It's like having a cast of actors, but giving them no script and no direction. But look on the right side. Here we see exam mastery. This means you are actively using precise terminology, you are explaining clear processes, you're comparing alternatives, and crucially, you are connecting everything directly back to the given scenario. To achieve this level of mastery, you really need to break down the assessment objectives specific to computer science. Examiners aren't just testing what you know, they are rigorously testing how you apply it under pressure. And how do the top students do this? They use the PEAL framework. That stands for point, evidence, explanation, link. It is an absolute game changer. You make your point about image storage. Then you provide your evidence, like mentioning the specific color depth. Next, you move into the explanation of how pixels are mapped out in binary. And finally, and this is where the magic happens, you link it right back to why the user's specific smartphone needs a compressed file in the first place. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you want this framework locked in. All right, moving on to Section 2, the procedural answering path. This is your disciplined methodology for writing flawless technical answers. Okay, what's really interesting about this next slide is how it breaks down the exact technical methodology you must follow in the exam hall. This is the Computer Science Success Blueprint. If you follow this 4-step path, you simply won't get lost. Step 1, identify the exact requirement. Look at the command word. Does it say state, describe, or evaluate? If it says evaluate and you just state, you've already lost. Step 2, classify the relevant data, hardware, software, or process. If we're talking about sound storage, are we classifying analog to digital converters? Know your equipment. Step 3, explain the process sequence clearly, step by step, no skipping ahead. Step 4, Connect the explanation back to the context. Let's do a live transformation right now. Remember Alex's flawed answer? Imagine Alex wrote this. Sound is stored in binary using sample rates. Honestly, that is a 1-mark answer at best. Let's run it through our 4 steps. First, we identify the requirement. The question actually asked to explain how sound is recorded. Next, we classify the hardware. We need a microphone and an ADC, an analog to digital converter. Now, for step 3, we explain the process clearly. Sound waves enter the microphone. The amplitude of those continuous waves is measured at set, regular intervals, which, by the way, is exactly what the sample rate is. And each of those measurements is then converted into a discrete binary value. Finally, step 4, we connect it to the context. This entire process allows the specific digital device to actually process and store the audio file. Do you see what just happened there? Notice how those red pen marks of failure completely transform into the green check marks of success? This step-by-step path absolutely prevents you from just writing everything you know without direction.
If there is literally one core principle you burn into your memory from today's explainer, let it be this one. Context is king. Think of context as your movie set. You wouldn't shoot a sci-fi scene in a Western saloon, right? The source material we rely on emphasizes time and time again that generic responses rarely gain full marks. Rarely. If the exam question gives you a specific digital scenario, say a smartphone downloading a high-definition video, or a modern website displaying a high-res image, or a retail system scanning barcodes, or even an embedded system in robotics, your answer must, and I mean must, stay strictly inside that specific digital scenario. You have to anchor your explanation to the exact details provided. If you just give a textbook definition of lossless compression without explaining why a professional photographer's portfolio website actually needs exact pixel-perfect recreation, you are throwing marks out the window. Always anchor to the set.
Let's jump into Section 3, 4 Prompts for Mastery. This is a highly reliable memory structure that works for absolutely any topic. But really quickly, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGC to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGC and turn on all notifications so you never miss our weekly exam strategy sessions. All right, we are now entering the interactive workshop phase of this explainer. I want you to be highly active right now. Sit up, pay attention, and get ready to think. To ensure you can always generate a complete answer, let's explore this 4-prompt memory structure. What is it? How does it work? Where is it used? Why is it better or worse? If you can answer these 4 prompts aloud for text, sound, image, or video storage, you are fully 100% ready for whatever the exam throws at you. Let's do Challenge 1, the data scan. Imagine a 60-second timer is ticking down right now on your screen. You're looking at a complex data table showing 2 audio files. File A has a 44.1 kHz sample rate. File B has an 8 kHz sample rate. The clock is ticking. To extract the core trend instantly, apply the 4 prompts. 1. What is it? It's a direct comparison of audio sample rates. 2. How does it work? Well, a higher sample rate means you are taking far more amplitude measurements per second. 3. Where is it used? File A, with its massive 44.1 kHz rate, is used for high-fidelity, studio-quality music. File B, at just 8 kHz, is used for basic, low-quality voice calls. 4. Why is it better or worse? File A has vastly better audio quality, giving a truer representation of the original sound, but, and here is the trade-off, it requires significantly more storage space and bandwidth. Did you catch that core trend before the buzzer? That is exactly how you use these prompts to decode complex data on the fly. This table shows exactly how applying those prompts makes the terminology deeply meaningful. You must always know 3 things: the purpose, the device, and the practicality. Now let's move into Challenge 2, Find the Flaw. I'm going to read a flawed sample computer science paragraph about video storage. I want you to listen extremely closely and take a quick mental second to spot the flaw. Ready? Here we go. A video is a sequence of images played quickly. To store the video on the security camera, the system uses lossless compression. This reduces the file size by permanently removing redundant data. The user can then store more footage. Okay, time's up. Did you spot it? The fatal flaw is saying lossless compression permanently removes redundant data. The examiner commentary on a sentence like this would be absolutely brutal. Lossless compression does not permanently remove data. It uses algorithms to pack the data more efficiently so it can be perfectly reconstructed. Permanently removing data, that is lossy compression. Furthermore, let's look at the practicality consequence for the user. For a continuously recording security camera, you probably actually need lossy compression to save massive amounts of space over time. But if your script claims it's lossless and then describes lossy, you have totally contradicted your own definition and tanked your score. You must always map your concept to the correct application focus. Let's transition to Section 4, Avoiding Classic Exam Errors. We need to navigate these common wrong turns. This quote, pulled straight from our official source material, highlights the harsh reality. Specificity is absolutely everything when answering data representation questions. Generic responses are the enemy of an A-star grade. Let's jump into Challenge 3, Speed Writing. You've got 30 seconds on the clock. I want you to mentally draft one perfect peel paragraph. Point, evidence, explanation, link, explaining why Unicode is preferred over ASCII for a global messaging application. Remember our rule from earlier, you must anchor to the details. And the key detail here is global messaging application. Go. All right, got our points together? Let's review what a perfect blockbuster answer looks like. Your point would establish that Unicode represents a significantly wider range of unique characters than ASCII. Your evidence is the raw data. Unicode uses 16 or sometimes even 32 bits per character, compared to ASCII's very limited 7 or 8 bits. Now for the explanation. You explain that having 16 bits allows for the binary representation of tens of thousands of different characters, including multiple distinct alphabets and emojis. And finally, the link. This is the crucial part that avoids the generic trap. You link it by stating that a global messaging application requires users to communicate in various languages, like Arabic, Mandarin, or Hindi, which ASCII's 256 character limits simply cannot support. Boom, full marks. Make sure you rigorously train yourself on contrasts, because the theoretical foundations of data storage often depend on distinguishing between very closely related concepts. Let's look at a few classic wrong turns. A massive one is confusing memory, like RAM, with storage, like an SSD or hard drive. You must distinguish them clearly. Memory is volatile. It is strictly for current, active processes and instructions that the CPU is executing right now. Storage, on the other hand, is non-volatile. It's for the long-term retention of files and software, even when the power's off. If you mix these up, the examiner assumes you don't understand computer architecture at all. Another incredibly common classic error is naming a device or a method without actually explaining how it works. Saying it uses a DAC gets you exactly one label mark, but detailing the actual pathway, explaining how the digital to analog converter takes discrete binary numbers and translates them into continuous electrical voltages to drive a speaker, that gets you the full suite of marks. And lastly, never ever give an advantage with no reason. Writing lossy compression is faster to download is an incomplete thought. The correct pathway is justifying your choices based on the scenario. Lossy compression reduces the overall file size by permanently removing unnoticeable color data, which therefore requires less bandwidth, resulting in a much faster download for a mobile user on a 4G network. Do you see the difference? Always detail the process. Finally, Section 5, the 3-pass revision cycle. How do we lock this knowledge in for real-world transfer?
This layered timeline ensures you move away from basic definitions and up to highly adaptable applied reasoning, which is exactly what the Cambridge IGCSE demands. Let's review the final system. There are 3 unbreakable rules that guarantee top marks if you follow them. Rule 1, command word decoding. You must always know if you are simply stating a fact or explaining a process. Rule 2, the Peel framework application. Point, evidence, explanation, link. Never make a naked point without linking it back to the prompt. Rule 3, the time management matrix. Do not spend 10 minutes writing an essay for a 3-mark question, and don't write a single sentence for an 8-mark question. You execute these rules through this highly effective 3-pass revision cycle. Pass 1, secure your key definitions and contrasts. You need to know your ASCII from your Unicode, your MIDI from your MP3, like the back of your hand. Pass 2, rehearse worked explanations. Physically draw out that analog to digital sound wave diagram on paper until you can do it with your eyes closed. Pass 3, test your exam adaptability. Do this by actively changing the scenarios. If you learned how image storage works for a high-end digital camera, stop and ask yourself, how does this explanation change if the scenario is suddenly a low-resolution web thumbnail? Students who implement these computer science strategies see an average improvement of 2 full grade boundaries, but that only happens if they practice consistently with our weekly content. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having the best strategy in your toolkit.
So as we wrap up this session, I want to leave you with a final provocative question to think about. Based on the 4 prompts we learned today, what is it, how does it work, where is it used, and why is it better or worse? What is the short, highly specific checklist you are personally going to use before submitting your next exam answer? I want you to drop a comment below right now with your target grade for computer science and the biggest challenge you're currently facing with these papers. Our team responds to absolutely every comment. Build your checklist, stick religiously to the digital scenario provided, and you will completely transform your results. Like and share this video with a study partner who needs to hear this. Ace the exams, your Cambridge success starts here. Keep exploring, keep testing your knowledge, and I will see you in the next one.